Hello everyone, welcome to the ITLS Academy. Today we are going to discuss another experiment in the series of adulteration, and here we are going to discuss about the adulteration in spices. Okay, so the experiment that we are going to perform, that is your detection of the foreign resin in a asa Asafoetida. Okay, so our sample is what? Our sample is Asafoetida, and the adulterant that we are going to discuss is a foreign resins. Okay, so we all know that adulteration or what? Adulteration is a process in which a substance are added into a food product to increase its quantity, to enhance its flavor, to enhance its color. That is called a adulteration. But ultimately the quality of that product are degraded. Okay, but quantity increases. That's why the manufacturer are added this adulterant into the food substance. Now during the adulteration, the substance which are added into the food product are known as the adulterant, and sometimes a good food ingredients are replaced by the bad food ingredient, that is also called adulteration. Okay, so we in the elimination of good ingredient with that bad ingredients is only that the bad ingredients are cheaper than the good ingredients. That's why the manufacturer or the supplier eliminate that in good food ingredients to that bad food ingredients. Okay, that is called adulteration. Okay, so the experiment that we are going to perform is what? The detection of the foreign resin into a acidophedata. Okay, so here the reason behind the addition of that foreign resins into the acidophedata is only to increase the quantity of that acidophedata. We all know that this acidophedata are what? They are costly. Okay, so when suppose that we are going to buy acidophedata into a market, and we want to buy around 10 gram. Okay, now in 10 gram what they do, they add 2 gram of this foreign resins. Now you pay for 10 gram of acidophedata, but you get what? Only 8 gram. 2 gram is what? 2 gram is the foreign resins. So the loss is what? Consumer face the loss. And this foreign resins also degraded the nutritional value of that acidophedata, also decreases the quality of the acidophedata. That's why it is very important to detect this foreign resins into the acidophedata. So for performing this experiment, we require two chemicals. One is your rectified spirit and another one is your ferric chloride 6%. Okay, now for the preparation of this ferric chloride 6%, we required a 6 gram of ferric chloride, and the 6 gram of ferric chloride are dissolved into 100 ml of the distilled water. Now how you dissolve this or how you prepare this solution? So for this what you have to do, you take a 6 gram of this ferric chloride and first you have to dissolve it into a 50 ml of the distilled water. When it is completely dissolved, then you have to add a remaining 50 ml of the distilled water into it and make a volume 100 ml. So that's how we prepare this ferric chloride. Now we required this conical flask for our filtration. We required a filter paper. We required a test tube stand, test tube holder, micropipette of 1000 microliter or 1 ml. We required a funnel for the filtration, then this dropper and spatula and micropipette tip. Okay, so for performing this experiment, we require this setup. Now, how you perform the experiment is very simple. First of all, one more thing that we required is a weighing balance. Okay, this weighing balance is also required for the weighing of that acidophtheta. Okay, now for performing this experiment, what we have to do, we take a 1 gram of acidophtheta and it will be dissolved into a 6 ml of that rectified spirit. Now after that we filter it by using our filter paper, and after that we take a 5 ml of the filtrate, and into 5 ml of that filtrate we have to add a 1 to 2 drop of ferric chloride. If a foreign resins are present into the acidophileta, then our solution turn into a olive green, which indicate that the presence of that foreign particle, foreign resins. Now take a test tube. First of all, we have to take a, obviously this is your acidophileta, that is our sample. Now we have to take a 1 ml of acidophileta. Don't forget to tear the weight of that aluminum foil. Add little amount, okay? Now this is around 1 gram. Now transfer this 1 gram acidophileta into the test tube. Transfer it very carefully. Okay. After that, what we have to do, we have to add a 6 ml rectified spirit. So we have a 1000 microliter or 1 ml of the this micropipette. So what we have to do, we have to add a 6 times. 1, 2, 3, 4, 5, and 6. Now dissolve it completely by shaking it. Then you have to filter it so that the solid particle remove out. And when you are filtering it, you have to only take a filtrate. You don't take a cake. Now we filter it by using this conical flask and a filter paper with the help of that funnel. Okay. Now filter it. It will take time. You have to take a 5 ml of the filtrate. Just wait for the filtration. See, the filtration are occur, we get a filtrate and the cake will remain at the filter paper. Now when it is completely filtered out, we take what? We take a 5 ml. So it will be around 5 ml. Now transfer this 5 ml of the filtrate into the test tube. Then after that you have to add a 1 to 2 drop of the ferric chloride into it. 1, 2. If a foreign resins are present, then this solution turn a olive green. See here, the solution does not turn a olive green, which means that our sample does not contain any acido, sorry, it does not contain any foreign resins. Okay, so this is all about the detection of this foreign resin into a acidophilus, which we get a negative result. So I hope you will understand, but if you have any query related to this experiment, you are freely to ask me in a comment box or for a further detail. You can follow the ITLS Academy on different platforms, that is your Instagram, Facebook, Twitter, YouTube, WhatsApp and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. You can also visit our website, that is your www.itlsacademy.com. Thank you for watching. Please like, share and subscribe our channel.